Hello guys, today I'm going to teach you how to step down the AC voltage by using the transformer. I will step down the voltage from 220 volts to 12 volts. Now let's bring the transformer. Go to the place of basic. This one. Click on it. Select transformer. Click OK. Click on the page of diagram of multisim. And then close the window. After that, change the setting of the transformer. Double click on the transformer. Change the number of the turns of the primary coil to 220. Click on the text of the primary coil. Write 220. Click on the text of the secondary coil. Write 12. Click OK. Now we have the transformer from 220 volt to a 12 volt. Let's bring the power supply. Go to the place source. This one. Click on it. Select power source. Choose AC power source. Click OK. Close the window. Now we have to change the setting of the AC power source. Double click on it. Change it to 220 volts and then click OK. Now the voltage of the source is 220 volt and the frequency of the source is a 60 Hz. Now we have to bring two voltmeters. Let's bring them. Go to the list of the measurement components. This one. Take 2 voltmeters. The 2 voltmeters can measure the DC voltage, but the 2 voltmeters cannot measure the AC voltage. Now we have to change the setting of the 2 voltameters to measure the AC voltage. Click on the first voltmeter. This one. Double click. Click on the second voltmeter. Double click. Change mode to AC. Click OK. Now we can start connection this circuit. Connect any pin of the source to any pin of the transformer, just like this. Connect the other pin of the source to the another pin of the transformer, just like this. We have to shift the circuit a little bit. Click on the left button of the mouse. Locate the circuit and move it to the right. Click on the left button of the mouse on the page of diagram to drop the circuit. After that, take one of the voltmeters to the left of the source, just like this. One click on the page of the diagram by the left button of the mouse to release the voltmeter. Now you can connect the voltmeter by the source. Connect any pin of the voltmeter to any pin of the power source, just like this. Connect the other pin of the voltmeter to the another pin of the power source, just like this. Click on the pin and click on the another pin of the power source. Now we have to connect the other voltmeter by other coil of the transformer. Take the voltmeter right and down. Click on it. Just like this. Click on the page of the diagram to release the voltmeter. Now you can connect the other voltmeter by other coil of the transformer, just like this. Now we need the ground. The ground is just important for simulation the circuits on multisim program. Let's bring the ground. Go to the place source. This one. Click on it. Choose power sources. Click on the ground. Click OK. Put it on the page of the diagram. Close the window. Now we have to connect the ground by the circuit, just like this. Click on it and click on the another point of the circuit. As you see, guys, the results on the voltmeters you can stop running this circuit by clicking on the red button above or stop button. This one. Click on it. You can add the load to this circuit. We will add it to the coil of the 12 volt. Let's bring the load. Go to the place indicator, this one, click on it. Select the group of lamp. Choose the lamp of the 12 volts 25 watt. Click OK. Click on the page of diagram. Close the window. Now we have to rotate this load. So click on the load, this one, by the left button of the mouse, and click on the right button of the mouse click rotate 90 degree clockwise, just like this. Now we have to connect this load by the coil of 12 volt, just like this. Also, we can see the input voltage and the output voltage of this circuit by using the oscilloscope. Let's bring it. Go to the right list, this one. Choose oscilloscope, this one. Click on it. Now we have to connect the oscilloscope by this circuit. We will connect the channel E of the oscilloscope to the input, and we will connect the channel B to the output. Let's start connection, just like this. As you see, guys, like this connection. Now you can run this circuit and you can see the input signal and the output signal. Let's run this circuit. Click on the green button above, this one. Click on it. As you see, guys, the lamp is on. You can see the input signal and the output signal by the oscilloscope. Double click on the oscilloscope to see the signals. Now we have to set the two channels of the oscilloscope. Change the oscilloscope mode from the DC mode to the AC mode. just like this. On the two channels. Now we have to set the amplitude of the two signals. Go to the scale of channel A. Click on it and increase it. That's enough. Go to the scale of channel B. Click on it and increase it. That's enough. The orange signal is the input and the red signal is the output. You can read the peak-to-peak voltage by using the pointers of the oscilloscope. Let's read the peak-to-peak voltage. First, stop running this circuit. Click on the stop button, this one. Second, keep holding on this button and shift the signals, just like that. Now you can move the pointers. Keep holding on one of the pointers and move it to the tops of the signals, just like this. Move the another pointer to the lowest points of the two signals, just like this. Now you can read the peak-to-peak voltage of channel A. The peak-to-peak voltage of channel A is 619. This one. Also, the peak-to-peak voltage of channel B is 33.7 volt. This one. There is a note about this transformer. This transformer is ideal. The primary coil and the secondary coil don't have the resistance and the inductance. The core of this transformer doesn't have the reluctance. The input frequency to the primary coil equals the output frequency of the secondary coil. You can measure the frequency by using the frequency counter. You can take the frequency counter from the right list. This one. Let's take it. put it on the page of diagram. Now we have to connect the frequency counter to the output, just like this. Also, we are going to put the current meters on the input of the transformer and the output. But before that, I have to shift the wire of the lamp to make the area for the meter. So I'm going to take out this wire, click delete. Now we have to connect another wire between the pin of the lamp and the pin of the voltmeter, just like this. There is a note, guys, about how to get the voltmeters and the current meters. So go to the ribbon of the results, nets, components, copper layers, simulation, and click on the space of this ribbon by the right button of the mouse. Now we have brought out the lists of multisim program. You will have to click on the list of measurement components, this one. After clicking on the list of measurement components, the list will appear such as this one. Also, you can use the multimeter on the right list, this one. Let's put the current meters on the input and the output of the transformer. Take the current meters from the list of measurement components. So click on the first component from left of the list, this one. Click on it and click on the page of diagram. Make another one. Click on it. Click on the page of diagram. Now I have to change the properties of the two current meters. Let's change the properties of the two current meters. Double click on the first meter to change its properties. Change mode to AC mode, from DC to AC. Now change the resistance of the ammeter. Make it lower and lower. That's enough. Click OK. Do the same thing with the another ammeter, just like this. Now the ammeters are ready to use. Now I'm going to insert this ammeter on the input of the transformer, just like that. The same movement with the another ammeter. Just like this. Now we can measure the input current and the output current of the transformer. This one for the input current and this for the output current. We don't need this ammeter, so remove it. Now you can run this circuit and see the currents of the input and the output, also the frequency. Let's run this circuit by clicking on the green button above. This one. Click on it. As you see the results on the meters, now I have to turn off this circuit because I want to measure the frequency of the secondary coil of the output. So turn off the circuit by clicking on the red button, this one. Click on it. And set the frequency counter. So double click on the frequency counter to set its properties. This one. Change the sensitivity from 3 to 12 volts. Increase it. That's enough. And change the coupling from DC mode to AC mode, just like this. Now the frequency counter is ready to use. Now you can again run this circuit and see the frequency of the secondary coil. Let's run it again by clicking on the green button above, this one. There is no result on the screen of the frequency counter. If you have like this situation, you have to reconnect the frequency counter to the another pin of the secondary coil of the transformer. You have to turn off the circuit, just like this. Now you can reconnect the frequency counter. So take off the window of the frequency counter, this one, just like this. Remove the wire of the frequency counter, this one. Reconnect the frequency counter to the another pin of the secondary coil of the transformer, just like this. Now you can run this circuit and see the frequency of the secondary coil of the transformer. I have to set the frequency counter again. I will change the sensitivity. I will make it lower from 12 volts because it's a theoretical frequency counter, not the real one. As you see, guys, the frequency on the screen of the frequency counter. It's time to give you all formulas about the ideal transformer. Here are the formulas about the ideal transformer. The first formula says the input frequency equals the output frequency equals the frequency. This is the formula. As you see, the formula says Fn equals F out equals F and F equals 16 Hertz. The second formula says the turn ratio equals the number of the turns of the primary over the number of the turns of the secondary. The formula A equals NB over NS. If you try this formula, A equals 220 turn over 12 turn equals 18.333, approximately equals 18.4. Also, the turn ratio equals the voltage of the primary over the voltage of the secondary. A equals VB over Vs. If you try the formula, A equals 220 volt over 12 volt equals 18.333 equals 18.4 approximately. This formula says the current of the secondary equals the current of the primary multiplied by the turn ratio. As you see, the formula IS equals IB multiplied by A. If you try the formula, Is equals 0.1137 ampere multiplied by 220 volt over 12 volt equals 0.1137 ampere multiplied by 18.4 equals 2 ampere point 084. We have formula of power which says the power of a load equals the voltage of the secondary multiplied by the current of a load. The formula B load equals the Vs multiplied by IL equals Vs multiplied Is. If you try this formula, you will find that B load equals 12 volt multiplied by 2.0833 ampere equals 25 watt. We have formula about the load DC resistance which says the load DC resistance equals the voltage of the load over the current of the load. I forgot something about the formula which talks about the load DC resistance. We have to add the word DC before the voltage and the current of this formula. So let's add it. Just like this. So we have changed this formula. So the right formula is the load DC resistance equals the DC voltage of a load over the DC current of a load. If you see the formula, the RL DC equals the VL over the IL. If you try the formula, the RL DC equals 12 volt over 2.0833 ampere equals 5.76 ohm. So in multisim program, by assuming that the load AC resistance equals the load DC resistance, because we have ignored the scan effect theorem. We have note, guys, the note about the scan effect. It says if we increase the frequency in hertz of the AC power source, the scan depth in meter will decrease, so the RAC is bigger than the RDC of the same resistive load. The current of the AC source will not be able to go to the center of the sectional area of the wire or the resistor or every conductive metal with a same current density. The current of the AC source differ by depth of the sectional area of the wire or the resistor or every conductive metal. The resistance of the load according to the primary equals the resistance of a load multiplied by the turn ratio squared. If you see the formula, the RL of the primary equals the RL on the secondary multiplied by A squared. If you try the formula, the RL of the primary equals 5.76 ohm multiplied by 18.333 squared equals 1935.999 ohm. The input power equals the current of the primary multiplied by the voltage of the primary. If you see the formula, the power N equals I primary multiplied by V primary. If you try the formula, Pn equals 0.1137 ampere multiplied by 220 volt equals 25 watt. The output power equals the current of the load squared multiplied by the resistance of a load. If you see the formula, the power out equals IL squared multiplied by RL. If you try the formula, power out equals 2.08333 ampere squared multiplied by 5.76 ohm equals 25 watt. The input power equals the output power equals the power of a load. If you see the formula, power N equals power out equals power load. If you try the formula, power equals 25 watt. The time cycle of the sine wave equals 1 over the frequency. If you see the formula, time equals 1 over the frequency. If you try the formula, time equals 1 over 16 hertz equals 0.01666 second. The current of the primary equals the voltage of the primary over the resistance of a load according to the primary. If you see the formula, I primary equals V primary over the RL according to the primary. If you try the formula, I primary equals 220 volts over 1935.9999 ohm equals 0.1137 ampere. So I have added 4 equations from number 15 to number 18. The power factor equals the cosine the shift between the wave of the voltage and the wave of the current in degrees. So let's call it alpha. If you see the formula, the power factor equals cosine alpha. If you try the formula, power factor equals cosine 0 equals 1 because the alpha is 0. The apparent power equals the power over the power factor. If you see the formula, the S equals P over the power factor. If you try the formula, S equals 25 watt over 1 equals 25 volt ampere. The reactive power equals the apparent power multiplied by sine alpha. If you see the formula, the Q equals S multiplied by sine alpha. If you try the formula, Q equals 25 volt ampere multiplied by sine 0 equals 0 var. The apparent power equals the square root of the quantity, the power squared plus the reactive power squared. If you see the formula, S equals squared the quantity P squared plus Q squared. If you try the formula, S equals the square root of the quantity 25 watt squared plus 0 var squared equals 25 volt ampere. Thank you for watching. See my YouTube channel. Don't see it alone, see it with others.